Hello, my name is Jacob Magnon, and this is the second lab for Physics 2212, which covers lines of charge. Let's get straight into it. To begin, let's have a look at the purpose of this lab. Today we will be improving the calculation of electric force between two pieces of tape from the experiment in our previous lab. Instead of treating our tape as a single point charge, we will now consider the entire length of tape and how charge is distributed across that distance. Then we will create a GlowScript code to model our calculations. Now looking ahead at the main results, we will have a code that calculates the force due to a small piece of tape and then iterates over the whole length of the tape. Finally, that code will display each small electric field, net electric force, and gravitational force, and we will compare the discovered charge on the tape compared to our results in Lab 1. Before we get into the code, let's look at some foundational information that we need to know. Newton's second law is important because it tells us that when neither tape is moving, the net force on each tape is zero. Coulomb's law and its corresponding formula are fundamental to describe the interactions between our charged tapes. The electric field and charge density formulas shown here will also be important when iterating through our code. Finally, we are going to assume in this lab that air resistance can be ignored and that the charged tapes have equal charges. Now we are ready to start making our code. First, I should note that our system is the top piece of tape and the surroundings are the bottom piece of tape and the earth. At the top here are some constants and my calculated value of charge Q, which is modified from my result in Lab 1. Under that, we have the function for the electric field, which takes in the particle emitting the field and the location we want to observe. At the bottom is a function to create each small piece of tape, and each is assigned a value of mass and charge using the charge density equation right here. Moving on, this code here functions to find the electric field and force of each small piece made in the previous function. This utilizes the electric field function shown on the last slide and also creates an arrow for each individual electric field. Finally, at the bottom here is the code for our net electric force and gravitational force arrows. The code will also print the magnitudes of each one right here. Now that the code is complete, this is the output of running it. As you can see, the electric and gravitational forces cancel out in the vertical direction, which is what we would expect as the tape is not moving. Also, the derived value of Q in this lab is about 2.49 times 10 to the negative 8th, which is about 2.21 times the estimate that we got in Lab 1. Looking at some of the questions for this lab, what if each tape had been modeled as a point charge? Well, this is exactly what we tried to do in the previous lab, so to answer this question, I compared those results to our new results. As shown here at the bottom, the charge derived from modeling a point charge was significantly smaller than our line charge model. Now you might ask, why do our estimates differ and which one is more accurate? To answer this, I would say that because we used many small pieces in our calculation in this lab compared to one large piece in Lab 1, that's why our results varied. The method used in Lab 2 is more accurate because it better resembles how the charge is spread over the entire length of the tape. By adding more and more pieces to our calculation, the results get closer to the actual answer. Some possible sources of error in this lab arise from our assumptions that I listed earlier in this video. Also, I estimated the weight of the tape and the length of the tape, which could have caused some error in our calculation. Finally, when the code is run, I chose to cut the tape into 25 small pieces, but if you wanted to add more, you would probably get a more accurate calculation of charge, but I did that just to limit how long the code would run. To conclude, in this lab we were able to computationally find the charge on a piece of tape by dividing it into smaller pieces and finding the electric field on each piece. We found that this method of deriving charge is more accurate than the method used in Lab 1, and we were able to display our net charges and electric fields using a GlowScript code. That's it for this lab. Thanks for watching.